Okay, I'm going to start. And 3.2 is really just a carryover of 3.1. A lot of what's given to you in 3.2, the alternate interiors theorem and the corresponding angles theorem and the alternating exterior angles theorem and same side interior theorem are theorems that I told you yesterday, but I didn't call them theorems. And all it means is if you've got an alternate, these are parallel, and a lot of times you're going to see parallel lines marked like that, and that will tell you it's parallel. There's no textbook check, so don't worry about it. This angle and this angle, right, are exterior, alternate exterior angles. Those two are congruent under the alternate exterior angles theorem. So I told you that yesterday, now it's just a carryover. These are congruent. If I do alternate interior, those are congruent. If I do corresponding, let's do this one and this one. See how those are corresponding? Those are congruent. And then the same side interior, here and here, are supplementary. Those are those four theorems in this section. Okay, that's all it means, is if you find two that are alternate interior, exterior, or corresponding, they're congruent. Two that are same side interior, they're supplementary, meaning their sum equals 180. Okay? And then the rest of the section is talking about if I have two lines and I'm not given that they're parallel, but I'm told this angle equals this angle, or I'm told this angle equals this angle, or this angle and this angle are supplementary, you get the idea, then I know they're parallel. So those are called the converse of the alternate interiors angle theorem and the exterior angles theorem and the converse. They're the converse of all those angles, those theorems. And all it means is if you have two sets of lines with a transversal, you can use the converse theorems to prove those two lines are parallel. If you're told they're parallel, you just use the regular theorem to prove those angles are equal. You understand the difference? Anybody listening? Just checking. Ferris? Anybody know Ferris Bueller? Nope.
Bueller,
You're going to have to.
I think I've heard of.
Have to watch it.
I've heard of Bueller.
I think I've watched something like it. I watched something my dad was watching something with it.
Anyway, so this is all a carryover from yesterday. Okay. The other thing that is talked about in this section is if this line is parallel to this one and this line is parallel to this one, then I know this line is parallel to this one, the transitive property. If this is parallel to this is parallel to this, then I know the first and the last are parallel. So if I have more than two parallel lines, you can use that property to prove other lines are parallel. Yeah. So it shouldn't be too bad of a section.
I was going to say, this seems pretty.
Yeah, it's not bad. Just remember the converse is used to prove lines parallel. The regular theorem is used to prove the angles are equal or supplementary if it's, of course, a same side interior.